In this video, we'll talk about variables, data types, and variable declaration. First of all, every programming language uses variables, and a variable is simply a container in the computer's memory where you as a programmer can store information. And so when you declare a variable, you're basically telling the computer how much space you're going to need in memory. And the way that you do that is by telling it the type, the data type of the information that you plan on storing there. So are you going to store long numbers or short numbers? Are you going to store strings like alphanumeric characters? Are you going to store dates or money? And so this is the reason that you have to declare or dimension a variable in order to set up the amount of space in memory that your application needs to store information. Okay, so let's get started. What I'm going to do is double click the button 1 in order to get the event stub for the click event. And then let's go ahead and declare our first variable. Alright, int counter, and then obviously I want to use the line separator. So what I'm doing here is I'm telling my application, I'm telling .NET that I want to create a space in memory that will hold an integer value. Now if you take a look in the workbook lesson number 7, you can see that I've got a little table in there about data types, and that the int data type can hold numbers between a negative 2.1 billion to a negative or to a positive 2.1 billion. So an example would be like 123 that we could put in here. The next part of the variable declaration is the name of the variable. In this case I called it counter. I can name this anything I want to, but in this case I may want to count how many times something in my application occurs. And so this brings us to a best practice, and that is that you should choose variable names that are descriptive of their purpose. And what this will lead to is self-documenting code that explains itself when you look at it. I could have just named this something like CTR, or I could even name something, name it as I, or any non-reserved keyword, and it would have worked just fine. But when I'm able to use a full word that is a little more descriptive of what I'm going to use this variable for within my application. Okay, before I go any further, let's just talk about one question that's commonly asked, and that is, do you have to dimension a variable in C#? Well, if you've ever used Visual Basic before, you were able to get away with not dimensioning a variable, but unlike Visual Basic, at least the older versions, you must dimension a variable in C#. You have no choice. But this is not a bad thing, because C# won't let you make a mistake by allowing you to create variables on the fly. That was one of the biggest problems with Visual Basic, and why they introduced the option explicit keyword into the programming language. So that's a little bit background in case you're trying to figure out, do you really need to dimension variables within C#? Let's briefly talk about another way that that Visual Basic is different than C#. And this will lead us to a discussion about type conversion. Let's do this for a second. We've been using the message box quite a bit up to this point, so let's go messagebox.show and then counter. So let's grab the value of counter. In fact, let's set the value of counter equal to 3. Okay. So now what should show up in the message box is the number 3. So let's run our application and see what happens. And what will happen is we'll get an exception. And the problem here is that you cannot convert an integer to a string. So we have a type conversion problem. What happens here is that the messagebox.show method is expecting a string to be used here in its little parameter. But we have an integer. And so what we need to do is convert one data type, in this case our counter that is currently an integer, and convert that to a string value. And a string, again, is just alphanumeric characters. They're not used in calculation, so you can't add strings together and get like a reliable output like 2 + 2 = 4. It might come out with something completely unreliable in that case. So in this case what we've done is a string conversion by calling the .toString method of the integer. And how this all works and what goes on behind the scenes, we're not going to talk about that now, but just suffice it to say that this data type integer has a built-in conversion function so that any variable that's declared as an integer can be converted to a string rather easily. So now that we've made that change, let's go ahead and run this application again. And this time when we click the button, we get the number 3. It's converted the integer 3 to a string 3, and so it was able to display that on screen. Now I realize that this might be rather confusing, but the more you work with it, the easier it'll be to understand. So let's just briefly recap what we've just done here in the last couple of minutes. First of all, we created a new variable of type integer called counter. We assigned a value to counter, counter equals 3, and then we displayed the value of counter in a message box by converting it from an integer to a string, which we could then pass to the show method of the message box object. So let's play with data types and declaring variables a little bit more. I'm going to declare another variable. This time it's going to be of type string, and I'm going to call this name. Okay? And so let's set name equal to Bob. Okay? And now let me show you that you can do something like this. Notice that I can take the value from one variable and I can assign it to the value of another variable. In this case, I had to do a type conversion so that it would fit properly within the space that was defined for it in memory. So I had to convert counter to a string in order to put it in a variable called name, which is of type string, but I can do it. Let's try the reverse. Do you think I can do this? Counter equals name. Let's give it a try and just see what happens when we try to run the application. Okay, it gives us a build error, so it wasn't able to build the application for us. And it says that it cannot implicitly convert type string to integer. So it tells us that we can't convert a string to an integer. What if I try to do something similar like toInt? Well, there is no toInt or toInteger. We could try taking int.parse and see if that will work and pass in a string. And how did I know that? It's just something I knew that you could do with an integer. You can try to parse a value and put it into an integer, but if Bob does not convert easily into a number, this won't work. So let's see if it'll work, just for kicks. Okay, it seemed to accept it. Alright, so it seems to work. It was able to convert the string number 3 because we've already assigned the number 3 to name, and then we took name and assigned it back to counter. So it was able to perform this just right. Let's do this. Let me get rid of this line of code by commenting out that line, and I use 2 forward slashes to do that. So this line will not get executed now. So now we're going to try and convert it to Bob into an integer. So I misspoke a little bit earlier. I apologize. Let's see if this works or not. Let's pull this over into view. Alright, and we're going to, I think, get a runtime error here. Yes. It says that input string was not in a correct format. So essentially it cannot convert Bob into an integer. In this case it was able to work because we converted 3 into our name and then took name and converted that back out. So let's just review here. We're able to convert data types back and forth between strings and integers. Now let's do something else. I'm going to delete these 2 lines of code here. What happens if I were to get rid of these quotation marks around our string and just try to assign name equals Bob? Will this work? Let's go ahead and run our application, and we get a build error. And it says the name Bob does not exist in the class or namespace. Okay, The fundamental problem here is that it thinks that Bob should be a variable, and yet we haven't defined it. See, if you don't use the quotation marks, then it doesn't realize that you're talking about a literal string value. So in this case, we have a literal string, which means that we want to put the value Bob into memory, as opposed to something we do like this, string Bob, and Bob equals Steve. And so now, whoops, let's name equals Bob, and then let's change this to Bob, or I'm sorry, let's change this to name and see what we get. So why didn't it print the value Bob? Well, because Bob is just a variable name. The literal value Steve was what was actually printed out to our application. So let's go ahead and get rid of this and get rid of this, and then add the quotation marks back. Now we've changed this back to a literal string, and then let's run the application, and we get Bob again. Okay, so that's the difference between a variable, at least the way that C# recognizes it, and a literal string. It's by the use of our quotation marks. Okay, finally, let's just ask the question that needs to be asked. Why do we need so many different data types? And we've only reviewed 2 data types within this video, but if you look in the lessons for Lesson 7, you'll note that I've listed probably about half a dozen or so, and there's probably 20 other data types that are available to you in C#. Why so many data types? And the reason is because we have different data needs. How will the application use the data? Will it try to add the data together? Will it try to display the data? Will it try to put the data in a database? All these things are factors in determining which data type to choose. But there's a pretty easy process to figure out what the right data type is, and that is that you should always use the smallest possible data type that still allows you to accomplish everything you need to with that particular data type or that particular variable. So in the case of a phone number, would you use an integer value or would you use a string value? Well, an integer value probably wouldn't work because you might have extra characters like alphanumeric characters. So that simply would rule out the use of an integer. In terms of currency, would you use a string for currency? Probably not, because you may need to add currency together, and you can't add 2 strings together like 10 cents and 15 cents and then expect to get 25 cents out. So that's one of the reasons why that you want to consider which data type. You want to use the smallest possible data type, but a data type that still allows you to do everything you need to do for your particular application in order to make things, get things to work appropriately. Now, I have purposefully oversimplified this topic. There's actually a lot of reading that you need to do. If you take a look at the extended reading sections for lesson number 7, you'll see that I've listed like 4 links there. And you really need to spend a lot of time. And yes, it's going to be challenging reading because one of the most challenging things about C# is the fact that the documentation is written in a more mathematical or scientific way than maybe the Visual Basic documentation. So this is one of the reasons why C# is a little bit harder to understand. It goes into more depth, and there's a lot more to this topic. So I just want you to understand that this is a very, very high-level overview of data types and how to select the right data type, how to declare variables, how to cast or how to convert one data type into another data type, and so on. So I trust that you'll do that before you move on to lesson number 8. Thank you.